Hey, this is a quick overview of how to use our development environment to work with RISC-V assembly language code and how to simulate execution of the code and debug execution of the code using the simulator that we're using, which is named Venus. So we're specifically using the Visual Studio Code extension to support Venus. Okay, so we'll have to start off with source code. Currently I'm working in this file called multiply.s. It contains a single function called multiply. The multiply function will take a multiplicand and a multiplier and surprisingly multiply them and produce a product. So it takes its arguments in A0 and A1 and produces a result and stores it in A0. Okay, so if I were to just use the run and debug button here, it would try and run this in the Venus emulator. But that doesn't really make much sense since this is meant to be a kind of a generic function. We want to use some sort of a test case on it. So like normal, we'll use some unit testing. We've provided a driver called multiply driver that will run several different unit tests on this. There's a task list over here. The task list will automatically run that driver. So I'm going to go ahead and click on the task list, and it tries to run the driver. When it does that, it opens up this 7-segment board. Now what I would have expected was a little set of buttons that would allow me to step over individual instructions, but I don't see that. And in fact, it looks like there was an error that occurred. So I can expand this little error tab, and it tells me, oh, multiply.s line 17, instruction with named oops is not found. Okay, so there's an error in my file. Notice the terminal tab here also says the same thing, and this is specifically a terminal for the Venus terminal. So again, Venus is the simulator we're using. So it looks like I have an error in my source code. So I'm going to go to multiply.s and go down to line 17, and that's definitely not a RISC-V instruction, so I'm going to go ahead and delete that. Okay, let's try that again. I'll try and run my unit test framework again, run multiply driver. This is what I expected. I expected to see these little buttons up here. So the buttons allow me to continue and execute test cases, step over individual lines, or step into lines. We'll talk about the differences between those two in just a second. So notice when it successfully runs, it again popped up this 7-segment board. I don't need that for this particular test case, so I'll move it out of the way a little bit and rearrange things here just a little bit. When the test cases are running, they'll also print things in this terminal window. So that might be where I need to look in order to find whether my test cases are successful or not. So when it starts running, it pauses at the first line of executable code. So it shows the line that it's currently on with this little arrow indicator. I'm just going to hit the play button and let it go ahead and execute and see what happens. Oh, and notice a whole bunch of error messages are popping up down there, and I went ahead and hit stop and stop the execution. Notice that it's showing all these test cases. It's multiplying a big number by another big number, and it got 6 as its answer. That certainly seems incorrect. So I'm going to go back and try and figure out what's going on here. So I'd like to kind of step through my code line by line, but I don't necessarily want to look at what's going on in this driver itself. I'm going to go ahead and start execution again, and then I'll hone in on my code and try and understand what's going on in my code specifically. So I'm going to go ahead and hit the run button. Okay, so again, it's kind of started at the beginning here, but I'm going to go to the file that I'm working in, multiply.s. I'm going to skim down here, and what I'd like to do is stop when it gets to my code. So over to the left of the numbers, I can click the button to add a breakpoint so it turns on the red dot. This has to be on an executable line, so I can't add a breakpoint to a comment. It won't stop on that. And even labels aren't necessarily able to do anything. So we have to find an executable line of code, add a breakpoint to it. Now if I were to hit this play button, it would execute until it gets to my line of code. So I'm going to go ahead and do that. I'm also going to look at the window down here and make sure I'm scrolled down to the bottom. So I'll go ahead and hit play, and it'll run through a lot of the test case framework until it gets to my code. Over here, it is showing the variables that are available. So by the way, sometimes this panel isn't being shown. So for example, if I'm looking at my tasks, it isn't being shown. If I want to be able to access those variables and register values, I can just click on the Run and Debug button here in the activity bar. So notice this has got several different kind of panels or panes in it. So one of them is for the variables. So it shows the program counter, which is the instruction that I'm currently on, the index of that instruction. What I'm really interested in at the moment is our registers. So we're only working with the integer registers at the moment, so I'm going to expand this tab of the integers registers, and here are the 32 registers that we've got available. So this function is expecting parameters in A0 and A1, so it looks like it's getting the number 2 and the number 3, and I would expect it to multiply those and get 6. It looks like it is just hard-coded to return the value 6. So I'm going to go ahead and continue to watch the execution of this. I will step over line by line. So I'm going to use the step over button. So we put the number 6 in the A0 register. I return. So now I've returned from my multiply function, and I'm back into this driver file. So it looks like the driver file is calling multiple functions. So that's what the JAL, jump and link instruction, does. So it called checkpoint regs, whatever that is. Then it called my multiply function, and now it's going to call check regs. Now, if I wanted to see what was going on in check regs, if I wanted to watch every single instruction as it's being executed, I could use the step into button. This is kind of the finest grained step we can take. It's a way to watch the execution of every single instruction. Often that's kind of overkill. A lot of times you're at a particular level of scope. You're in a function and you want to watch what happens inside of this function and want the functions that are being called to run to completion. So that's what the step over button does. I'm going to step over this line of code. Basically, it will execute the checkregs function in its entirety and move on to the next line. So step over just allows you to stay at your current level of scope. And so it ran this to completion, it did a whole bunch of stuff, and now I'm back at the next line of code after that in this driver function. And if I continue to run this, I can kind of watch what goes on in the driver. Again, I'm not super concerned about the driver. I'd like to understand a little bit more about why I'm failing test cases, although it's pretty clear why multiply isn't multiplying. I'm going to go ahead and stop this, and in many of these driver files, the top of the file describes the test cases and how they're being run and gives you enough context so you can edit the test cases yourself. So in this case, it says there are 3 values per line: the multiplicand, the multiplier, and the expected result. So the first test case that we were seeing being run is multiplying 2 by 3, and it's expecting to get the value 6. This is the test case I'm passing. And then the next test case is multiplying 122 by 376 and would expect to get 45,872 as the result. And it's running all these test cases. Now, if I want to debug what's going wrong, if it's just a couple of test cases that are failing, or even if it's an overwhelming number of test cases, I may want to hone in on just a couple of test cases. So I'm going to go ahead and comment out a whole bunch of these test cases. So it looks like all these things that begin with .word are test cases. I'm going to comment all those out, but I'm going to make sure that I don't comment out anything beyond that. So I'm going to go ahead and save my changes here. So I've commented out up to line 230. So if I were to run this again now, I've just got these 2 test cases, and I don't know, maybe I want to change one of these test cases. I could add another one if I wanted to. So I'm going to go ahead and rerun my program with just these 2 test cases, and we'll kind of watch what happens when it executes. So I'm going to go ahead and rerun it. Again, it's kind of stopped me at the top level of scope. I'm just going to let it run in its entirety. It stopped at my breakpoint. I'd like to get rid of that breakpoint. I could either remove the breakpoint by clicking here, and that would remove it altogether. Or if I just want to temporarily disable it, which is what I'll do now, I'll go ahead and click down here over in the breakpoint section of the Venus Controls tab. So, okay, it runs to execution, to completion. It looks like it ran 2 test cases, multiplied 2 times 3 and got 6 correctly. It multiplied 122 by 376, still got 6, which was incorrect. And then one of the 2 test cases that it ran passed. And it exited with error code 0. Okay, so that gives you kind of an overview of how to run Venus. One or two other little tips here. Every once in a while, you'll get into a phase where you get maybe multiple instances of it running. So I'm going to go ahead and run this again. And if I were to click run again, it's going to prompt me and say, it's already running. Do you want to run another instance? Normally, you want to press cancel. You don't want to run additional instances. If you accidentally press yes, you'll notice that the little control bar here has added a drop down where you can pick between the two different instances of the program that are currently running. I'm going to pick that second one that I didn't mean to run it a second time, and I'm going to go ahead and hit stop on that one. Okay, a couple other tips. Maybe if I have a small error, I want to fix it. So maybe I didn't want this to return 6. Maybe I wanted it to return 65. So rather than stop my simulator, I'm just going to go ahead and make those changes. As long as there aren't syntax change errors, I can actually just hit the reload button and restart my test program from the top. So if you want to quickly patch up something and you're careful not to make any syntax errors, you can just update your code, make sure you save any changes, and just hit the reload button to dynamically reload the driver. It starts it over at the beginning. So I'm going to go ahead and run this to completion. Oh, now I failed both tests. Oh no. Back to the drawing board.